So good morning. And actually we already have the arrival that says right here for the single server queuing system. Well, so for our simulation we need to have an example, and currently we already have the single server queuing system. And this single server queuing system we will use MM1. Later, all right. But we already have arrive the part and the others. So we check arrive. That's we, but we will review the arrive procedure again. Well, for this one, single server queuing system. This one applicable to the single server queuing system. So you can see we have the arrival event. And then we will schedule the next arrival event. Alright, because of the event trigger. And we will check server busy or not. If server it is not busy. So here, well, arrival server not busy. So this customer can enter the service facility immediately. Because of that, so the delay. Well, previously maybe some of you think, okay, why delay is 0? This delay is queuing delay. All right. Customer here and enter the server immediately. So of course the queuing delay is 0. So we can set delay to 0 and get the statistic, delay 0. And delay 0, next one, we have actually, this is a counter. It is called number of customer delay. In fact, this one is sample size. All right, sample size for queuing delay. Therefore, we want to collect sample size for the customer with the queuing delay. So that's why customer delay. Right. So this one is sample size. And we know queuing delay is 0, so of course we can increase the sample size. And then we can make server busy and schedule next departure because of event driven. So we can schedule the departure for this customer and then return to the main program. All right, so this is for you, actually it should be the right range. All right. And if server is busy, so you can add this one to queue, and so that you should increase queue size. So add 1 to the number of the queue that says it's queue size. Oh, the queue, oh sorry, not queue size, actually it should be queue length. Alright, it should be queue length. And we have these added to the queue. So we have the queue length, and we will check queue is full or not. Why? We don't know, we use array. But we have M1 actually is infinity. So the buffer size should be infinity. But we use array to implement the buffer. So if we have more customer than the array size, that says the current queue. So we have the array to have the implementation, then we will check this. If you don't use array to implement the buffer size, then we won't have this checking. However, it's array, so we will have the checking. Is the queue full? If yes, sure, something wrong, so we will write error message and start simulation because the current array size is small to accommodate all customers. So we will stop. Or otherwise, okay, no problem. So we will store the time of the current customer and return to the main program. So this is a review for the procedure of arrive. All right, is it okay? So next one. So after now we have this. This is a reminder. We have arrive, and we have a server, and we will have the departure, or here depart. Previously it's arrive. Alright, and actually arrive will be associated with the server. So that's why I will check server busy or not. And right now, from server to the end of departure, therefore we have the departure, actually leaving the server. Departure event. So we will check departure, still we will check the buffer. Is the queue or is the buffer empty? If yes, then no more customers. So the server will be busy. So make the server idle and eliminate the current departure event from consideration. Alright, so we have a one customer to depart. If the queue is empty, then make the server idle and eliminate the current departure event. So this is a left range. And the right range says not empty, so it can leave, and then we can find 1, 2 process and to serve their customer. So you can subtract 1 from the number in queue that says subtract queue length and compute delay of customer entering service and gather statistic. What that means. Well, if the current customer entering the server, then we have a time instant. For example, okay, here, this is time instant. Actually, we have an array to store the time of arrival. So you can use the current time minus the arrival time. So you will have the queuing delay. That says compute delay. Again, the delay here is queuing delay. Alright, so the delay here is queuing delay again. And how to compute? Let me say this again. Currently, we need to process. So we have the current time. And you can use the current time minus the arrival time of that customer. Which customer? The customer entering the server. Alright, so then you will have the queuing delay. Because you can have the queuing delay. Therefore, again, increase the sample size. Again, number of customer delay is sample size. Alright, sample size, so we know the delay, therefore we increase the sample size. And similar to the procedure of arrive, you will schedule a departure for this customer. And same, maybe not the same, sorry. We will move each customer in queue. If we rotate from bottom to up, and then we will move each customer in queue up one place. But right now, move right one place. That says, oh, okay, one enter, so you need to shift, shift, shift. Each customer in queue should be shifted to maybe the place near the server. Well, so this is the right branch of the departure procedure. All right, so you can check it. And right now, maybe allow you to have 2 minutes to discuss with your members. And also, I already have the standing page of the groups. So feel free to discuss with your neighbors. One. CP.
Like the same rules as.
Maybe not the same.
And not the same.
Yeah. Oh, all stay together. Okay, sure. Oh, right. You can rotate the table. So I think good one, okay, hold, and good to there, it's okay. And maybe 2 of you come here, good fold. How do you say? How do you say? I just said it? Yeah. All right, that's correct. And 1 more minute if you still want to discuss this one. The part for you. All right. Feel free to discuss. All right, so the initial, I think initially for the procedure of arrival is okay, right? And how about current procedure? Departure. Okay, or any questions? So let me check with group one. Group one, is it okay?
Functionality of delay.
Delay is queuing delay. And queuing delay says, here we have a server. And if I am the customer entering the server, Then you find the time instant right to be served. So you have the time instant right to be served, and minus the arrival time of this customer. So this is the queuing delay. Alright. So about the queuing delay, you can use the current time, because the current time to process a customer to be served. So you have the current time. And the current time minus the arrival time. The arrival time stored in the queue, in the array. So it should be okay, right?
Right.
Okay, good. And good 2? Okay, and good 3? Okay, thank you. And good 4? Alright, so this is the depart or departure. So let me move on. Should be okay, right? And actually the same, I use, maybe previously here it should be a poll to ask you any question, but I check with you directly. So right now, let us apply the previous flow chart for the single server Kingston to the specific one, MM1. Actually, it should be MM1 and infinity. Alright, so M means exponential inter-arrival time, and likewise here, exponential service time, and here one single server. And infinite means the buffer size. Alright. For example, current table. It is a server. So we have the buffer. The buffer size is infinite. So you can come here and come here and come here, and you can line up here. Alright. And how many customers? Infinite. So we allow infinite customers to stay in queue. However, buffer, in the first version of the C programming language, we use array. Let me mention this again, array. So array, we need to associate a size with this array. So that's why, the original problem should be infinite size buffer, but array, so we change it to maybe some large, but finite size of the buffer. So it's incorrect because of the setting incorrect. So we need to check. The queue, currently the queue is a finite size queue. The queue full, if the queue is full, then it's error. So we will have the error report. Alright. Well, so also currently this is a single server queuing system. And we change this to MM1, so we have the distribution. Exponential, the simplest one currently is exponential. So we have the exponential inter-arrival time and the exponential service time. So we will have two versions. Version 1, it's array, and we use the size to keep sample size smaller than or larger than the threshold. So version 1 we will use the sample size to control when to start simulation. For example, the threshold set it to 100. I want to increase the sample size here, 100. Or maybe you can set 100 to 1000, maybe all the other size. So you can use this way to control. And version 2, we use time. Alright, we use time to start simulation. Alright, so let me move on to the next one. Well, you can have the source code If you can find the password, then you can have the source code. Of course, I will upload the source code to you for reference. All right. And currently, we use C programming language. All right. If you are not familiar with the C programming language, you can have porting. From C to your language. All right, any language. For example, you want to use Python, that's fine. Well, currently is the paragraph of C programming language. You see, we have some definition, and we need to include. So include some library, stdio, standard input and output, and include math. We need to have the calculation, so we need to include math. And what it means, .h, it's the header file. All right, .h is the header file. Well, maybe you will notice this one. We include lcg rent.h. And we have a double quotation marks here. Why? Because the current one put it to the current directory. And for the others, it should be the default directory. So this is the difference. And you have the definition defined. Queue limit. Well, I don't know it should be infinite size, but why we set queue limit to 100? Because of array. Because of array. The implementation of an array, of course, we will have the limit queue length. However, the original one, we won't have the limitation. Because of array, so we still have the limitation. And status, server busy, idle, use 1 or 0. All right. And here we have type of the data, integer, floating number, and here it's 5. All right, we have all these later. If we use them, then we will let it know. And actually, we have the other procedure. So procedure or function. All right, so we have the other procedure initialization. And the timing, arrive, depart, report, update, time, average statistics. Time average says, oh, we have time, goes up, and down. So we want to find the mean value. So we have the update time average statistic. Update, it doesn't mean we have the time average directly, but we need to have the accumulation. And finally, we have the exponential. Well, remember, we have the way to generate exponential. So let me get back to way of generate exponential quickly. This one. How to generate exponential? We already have the way to generate exponential. Use minus beta multiply a logarithm u. U is the random number for in between 0 and 1. And calculation logarithm u multiply minus beta. Beta is the mean time. Why? I simply use mean time. Is mean time, and the mean time here can be mean interrupt time. Go forward. Mean inter-arrival time. O is the mean service time. All right, so it can be mean service time or inter-arrival time. So both of them can use this parameter, but they are not the same value possibly. All right, so we can use this one. So later we will have the formula directly. And you can refer to our slides and the slides that have the reason. All right, it says, okay, yes, the formula is correct to have the exponential random variable. All right, so we have the preparation here. Something like before the main program, we have the preparation. So we will have main later here. All right, so we have some definition before the main program, and we then have the main program for this page, and that's it. All right, so I think maybe if everything's okay with you using the C programming language, I think nothing wrong. And if you are not familiar with the C programming language, I then have some description for this. All right, so about this, then you have 1 minute to discuss with your neighbors. So before, maybe you can rotate the tables. So about the current setting, it should be okay, right? So then we move on. You see, main. And look here again. We have the description before main. And so that we have main immediately. And actually main will have the possible arrangement by invoking says calling the functions. Well, so you see we will have the calling of some function necessary function. So we can have here we have the input. We have the output, and so we will have F open. So we use F open, file open. All right, and file open, of course, first one R means read, and W means write. I think you know these, read and write. And of course here, read from the in file. So we have mm1 dot in. This is a name, all right? It should be the file. In fact, the file should be text file. But we have mm1.in and the next one out, so mm1.out. We have a file name. And so that we have the corresponding here. We have maybe you can treat, okay, something to denote the in file, and something to denote the out file if we don't have the specific details. So in and out file. So in file and out file. All right. Or maybe you can think, okay, this one is serving as a, for example, it's a file pointer or something else. And currently, number events. In fact, we will have the remarks for you, but I mentioned this already. Number of events, we have arrival, we have departures, of course. Number of event equal to 2. All right. And read input parameter using f-scan file. For me, okay, this is file and scan, but you have f again. So here, read file. All right, read the file. You see, read the file. We use here you can call is the in file parameter. We use the in file parameter. Read this one using the in file parameter. But how to read it? We will have the format. All right. For the in file, you will put enter arrival time, and you will have mean service time, and you will have sample size, number delays required. Previously, it should be sample size, number customer delayed. But right now, we use number delayed required. Required says we need to reach that sample size, so it's the threshold. So the current in file, you will have 1, 2, 3. The first one, for example, within the file, you can see the first one, just it's a array. Sorry, it's a row. The row containing three elements. Element 1, enter arrival time. Element 2, service time, mean service time. Element 3, the threshold of the sample size. Okay, so of course you will have the mn1.in containing three elements like this with the proper separation. And how to read and how to have the type. First one, mean enter arrival time. It should be floating point. Floating point using f. And the mean service time same. Floating point, for example, 1.1. Same floating point. And d means integer. It's d. So number delay required. All right. So f means floating point. And d actually is integer. And we have the others. Here, f print f. So printf says we need to printing. And print says here we want to print to the file, our file. And our file here we have a string. String says some sentences. Single server print system. And /a means new line. New line says move cursor to the next one, move cursor, 游标, move cursor to the next line, and move cursor to the next line. So new line, new line. And likewise, you have the output, mean enter arrival time, and mean enter arrival time. So here, mean enter arrival time says, oh, okay, I expect to have the mean enter arrival time. Because we have here, n says we want to get Alright, so n says we want to get the parameter and print the parameter. Alright, so for example, it is 1.5. So you will say, okay, output file to store. The current parameter is mean internal time, and the current parameter is the mean service time, and the current threshold is this. But we have for the weight 11.3 says the digits before the decimal point is 11. And after is 3, before is 16, after is 3, and here we have 14. Alright, so the number here says before point here we have 11, after we have 3, 16, and 3. If you don't think so, you can change the number. I just want to have 2. I just want to have 4 before the decimal point. 就小数点以前，小数点以后。Alright, so here, no decimal point, so we have 14. So currently it says we need to read the file and we prepare to send to the output file. Then we will have initialization because you need to have the initialization, the formal preparation for some parameter settings, so initialize. And then we have the others. So this one. And about this one, maybe that you have 2 minutes to check with your neighbors. Okay, go and check it, even it's simple.
Where this number will be stored. Yeah. Yeah, like first row will be stored into mean interval. Second bit means service and number delays required.
So after now, this is the initial, maybe initial arrangement for main program. And then we will have initial description of the main program. And in fact, to run the simulation, we will have initialize. So later we will have initialize. Or maybe let me jump to initialize. Here, initialize. Alright, so we will have the initialization. Initialization says we need to set the initial value for counters. Or some variables. Alright, so what kind of variables? Simulation time from 0. And server status idle. And number in queue from 0. And time last event, previous time, so it's 0 again. And here maybe you will notice 0.0 says it's a floating number, and 0 says it's an integer. All right, so we have a floating number or integer, and here we try to emphasize it should be 0.0 is a floating point number, so float. And sample size from 0, and the total of delay, total means the accumulated delay, so same. Right now, no, so it's 0. And the area 0, server status 0. Area of a server status 0. And here, time next event, 1 here. 1 here means arrival. And 2 here, departure. And arrival, how to have arrival? First arrival, current time is 0, plus exponential mean inter-arrival time. So of course, use the function, we will have the first arrival. And for next departure, departure should be infinity. But how to infinity? Infinity here. For example, you can have the definition infinity to a really large. Alright, really large number. And here, really large number says 1.0 multiply exponential raised, it should be 10, not exponential. 10 raised power to 30. And really large, right? So we think, okay, this one is infinity. Or maybe you can have the formal definition, define INF, and set it to a really large number. So you can have the way to have infinity. Alright, so this is initial. It should be okay, right? And let me check quickly any questions for the initialization. No problem, right? Alright, so we can have the initialize to have the initialization. And next one, run the simulation. The simulation, the goal for us actually, we want to have, we can check the report, then we want to know the goal. We will have the collection. And how to have the collection, you see, we use while. And while here we have a condition. The condition says, when number customer delayed. So sample size smaller than the threshold, then we will collect. And to collect, of course, we need to find using timing first. Code timing will that we have the next event. Alright, so timing says we need to find which time to have the next event. Alright, so which time is sent to have the next event. So, okay, we believe timing allows us to have the next event. Alright, timing allows us to have the next event. So allow us to have the next event, and then we have the rough idea. Alright, so for example here, time is 1. It should be arrival. Time is 2. It should be departure. And about the timing, the goal for the function of timing just want to find which one occurred earliest. And choose that one and return that one. And so, okay, next one should be arrival. Or maybe exchange it. Here is the departure and that is the arrival. Oh, we determine this is the departure. So we just want to know next event and what is the next event. It should be arrival or it should be a departure. So timing here. So up to now I didn't have the idea of timing. determine the next event, and also know the type of the event, arrival or departure. And next one, update time average statistical accumulators. All right, so calling function, update time average statistic. Update time average statistic, the current function manifold the area. We want to accumulate the area. You see, something like we have a timer. And because of event-driven simulation, so the current time, that says we will have a time less event. And for example, currently it's a time less event. We store time less event once we finish some of the statistics. So the current time, but we will move to a new event time. So we will have the actual area, right? Actual area to accumulate. For example, current area for queue delay, current area for server busy or not. We have, for example, 5.1 for the current area. And once we move further, then we will have the actual area. So update time average statistic, just try to accumulate area further. Until, all right, so this is the final time instant to start the simulation. So we have a time, we have the updated area, so we can use the time serving as the denominator, 分母, and using the accumulated area in the numerator, 分子. So we have the ratio, and then you can have the result. That says update time average statistic says updated area. And we will invoke further. Here we have the event using timing, and here using switch. Switch something like, oh, here I am the maybe the current switch. Knowing some switch, you see, if we have the switch or router switch, oh, it's yours and it's yours, so switch something like that. Switch using next event time. Next event time is arrival or departure. So case 1 says, the first case is 1, value 1. The first one is value 2. So case 1 says it's case of value. Case of value 1 and 2. We will associate 1 to arrival, 2 to departure. Right? Arrival, departure. And you see, because of the association, arrival, so of course we call arrive. And because of it, we call depart. And break says, once finished, we need to break the current switch and go to the next one. And next one says, while, break. So we try again, Here, the threshold reach. So the threshold reach, then the simulation is done. Simulation is done, then we can dump. We can dump. That says we can dump so that we have the statistics. Then we can have the report. And then we will have the report. I don't know. Update time at statistics. Update the area. So when we will have the statistic here within the report over the time. So you will have the measure, and the others over the sample size will have the measure within these. Well, once we reach to have the report, then it's done. It's done, but don't forget to file close, in file, file close, it's out file, right? And actually for the others, for example, if you have the pointer, then for the pointer you need to have the proper processing, or otherwise, for example, memory allocation. Oh, you get the memory dot. If you don't free the memory, then you will have a problem. Alright. And likewise, file. Similar, you have the occupation of a memory, so you need to free the memory. Free the memory, and finally return 0. Return 0 is a C program states. Everything is okay, so return 0. If non-zero, says error. Alright, but return 0. So that says for a C program in the main program, the final one should be return 0. Alright, and actually you can try. How about skip the current line, return 0? As I remember, it should be okay, but no, you don't have any value to check main. So everything will be okay. However, for the normal situation, you should let the system know, okay, the current one is okay, so return 0. Sometimes if you have a function, maybe not return 0, you will return non-zero, and then you will use that value to check something wrong. Alright, so you have non-zero, then you will have something wrong. But for main program, normally everything is okay, so we have return 0 here for the final line. And maybe you think if it's abnormal. It's abnormal, maybe not the final line. Okay, before this, maybe here. Oh, break, and something wrong, so return, for example, return 1, return 2, return 3, or return the others. Everything is okay. But non-zero, then it will have an error report. Alright, so this is the main program. And currently, it's a time for us to take a break. And from the email and from the syllabus, you know, we have a time reschedule. So 5-minute break only. And take a rest, and you can discuss if you think you want to discuss. Alright, that's it. Take a break.